Hello team, my name is Shubham. I hope you are doing great. First of all, thank you very much for giving me this opportunity. And in this session, I am going to record one demo video for gigs and on the topic of VLSM subnetting. And I hope you enjoy this demo. Now, without any delay, let's start the topic. So the topic of the day is subnetting VLSM. Fine. So before I start, first of all, we need to know what do you mean by subnetting. Fine. So I already written one definition here. Subnetting is the process of dividing a large network into a smaller, more manageable network. Yes, that is the basic definition which you will get in multiple books. Fine. But according to me, subnetting means just create the subnetwork. According to me, subnetting means just to create the subnetwork. Fine. Now, what do you mean by subnetwork? Fine. For example, if company provide you any primary network, fine, and you know in that primary network the number of IPs will be high. Fine. So if you already assign that primary network to any one client, then it means you will waste multiple of IP address. Fine. So that is the main advantage or that is the main use of subnetting. Fine. So by the help of subnetting, what we will do, we will just divide that one primary network into sub network. Fine. And we will assign that sub network according to the requirement. Fine. Now, when we are performing the subnetting, or you can say when we are creating the sub network, the method is different. Fine. Total, there are two methods by which you can perform the subnetting. First one is called FLSM and second one is called VLSM. Fine. FLSM stands for fixed length subnet mask and VLSM stands for variable length subnet mask. Fine. Now, when you read the FLSM, what is the full form of FLSM? Fixed length subnet mask. When I read the full form of FLSM, I am getting one thing, fixed length subnet mask. It means when we perform the subnetting by FLSM and when we create the multiple subnetwork, the number of usable IP address in each subnet will be fixed. Fine. That is FLSM. Fine. I am just giving you one example. For example, if I have one network 192.168.10.0/24. Fine. When you perform the FLSM here, what you will get? We will get total 4 subnet. We will get total 4 subnet. See, these are the 4 subnet you will get. These are the 4 subnet you will get. One subnet is, this is the subnet network 192.168.10.0/26. Second one is 192.168.10.64/26. Third one is 128 and fourth one is 192. When you read all the 4 subnet, what is the common? That is 26. That is common in every subnet. Fine. And this is the range. This is the range of each subnet. Getting my point? So what is the range? For example, subnet 1. What is the range? 192.168.10.0 to 192.168.10.63. That is the range. And the first one is called network ID and the last one is called broadcast ID. Right? And you can say this is the end point. And generally, we are not assigning these two address to any device. It means usable IP address you will get from 192.168.10.1 to 192.168.10.62. It means 62 usable IP address we are getting. Fine. It means for every subnetwork, from every subnetwork, the usable IP address you will get 62. And that is fixed. That is fixed. Fine. Now, what is the problem in FLSM? In a networking, please keep in mind, previously we are using the FLSM. Definitely in FLSM, there are some disadvantages. That's the reason we move towards the VLSM, right? So what is the problem in FLSM? For example, try to understand the problem. For example, we have total 4 client. Total 4 client. For example, this client is, for example, FedEx. The client name is FedEx. For example, this is Cisco, this is Webex, and this is. So there are 4 clients and every clients have different requirement. For example, FedEx have 10 requirement. Cisco has 2 requirement. Webex has 100 requirement, Zoom has 200 requirement. Fine. It means every client has different requirement. For example, your company provide you this network and you are providing the FLSM here. And let's suppose to FedEx you provide 192.168.10.0/26 this network. For example, Cisco you 192.168.10.64/26, and to Zoom you provide, for example, 192.168.10.192/26. What is the problem we are getting here? The main problem we are getting here, for example, to FedEx, the number of usable IP addresses, usable IP address is 62, right? You are providing this network, and in this network, the number of usable IP address is 62. But in FedEx, what is the requirement? Requirement is only 10. It means definitely you are wasting multiple IP address here. Yes, we are wasting multiple IP address here. For example, Cisco requirement is 2, and you are providing this network. You are providing this network, and in this network, the number of usable IP address is 62. So definitely you are wasting 60 IP address here. Yes. Fine. So this is the first problem we are getting. If we are performing the FLSM, what we are doing? We are wasting the multiple IP address. Fine. Now come to the Zoom. In Zoom, requirement is 200. For example, you are providing this one, but max to max usable IP address is how much? 62. It means if you are providing this network, Zoom's requirement will not fulfill. Zoom requirement will not fulfill, and you will not tell the client. You will not tell the client you use this one. I will provide you the 3 different subnet. Use it. No, that is not the solution. That is not the solution. Client want any one subnet. Client want any one subnet, and by the help of one subnet, his requirement should fulfill. Getting my point, everyone? So, what is the 2 problem in FLSM we are getting? The first one, we are wasting the IP address. Fine. And the second, what? In some case where we have a different clients with different requirement, with the help of FLSM, you can't fulfill the requirement. Fine. That is the main problem of FLSM. Fine. So that's the reason we have a concept of VLSM. In VLSM stands for variable length. It means by the help of VLSM, we will solve these 2 problems. First, we will avoid the wastage of IP address, and second one is we will assign the network according to the requirement. Fine. So that is the use of VLSM. Fine. Now we will discuss about the VLSM. Fine. Before start the VLSM, I am showing you one topology, and this is the requirement. Fine. For example, my company told me I am providing you 192.168.10.0/24. This is the primary network. Fine. This is the primary network. For example, my company is telling I am providing you 192.168.10.0/24, and you are the network administrator. And in my company, there are 4 clients. There are 4 clients, and all the 4 clients are sitting in different floors or different towers. For example, in my case, there are tower 5, there are tower 6, there are tower 7, and there are tower 8. Fine. And on each tower, there are different clients. For example, on tower number 5, there is a Zoom, here Webex, here Google, and here is Cisco. And see, every clients have different requirement. Fine. Zoom's requirement is 10 IP. Webex requirement is only 2 IP. Google requirement is only 50 IP, and Cisco requirement is only 100 IP. Fine. Every clients have different requirement. Now, and my company already provide me one primary network, that is 192.168.10.0. If we perform FLSM, can we achieve the task? Answer is no, because every clients have different requirement, and by the help of FLSM, we can't achieve these tasks. Fine. So in this case, what we need to do? We need to perform the VLSM. We need to perform the VLSM. Fine, everyone. Now the thing is how we can perform the VLSM. Okay, so before start the VLSM, try to understand the scenario. What is our scenario? We have total 4 clients, and all the 4 clients are sitting on different tower with different requirement. Fine. So the first client was, what is the first client? See, first client is Zoom. Zoom requirement is 10. Webex requirement is how much? 2. Fine. So let's suppose that is Zoom, and requirement is 10. That is Webex requirement is 2. Fine. Now come to the Google and Cisco. Google requirement is 50 and Cisco requirement is 100. Google requirement is 50 and Cisco requirement is 100. Fine. That is our requirement. Fine. Now before start the VLSM, we need to keep in mind one formula. We need to keep in mind one formula to calculate the number of subnet or IPs. Okay, so see, we have a primary network 192.168.10.0/24. That is the primary network we have. Fine. Now come to the zoom. Fine. We are starting with the zoom. What is the formula? 2 the power n minus 2 less than equal to number of requirement. Fine. So 2 the power n minus 2 less than is equal to, what is the number of requirement, guys? 10. Fine. Now you have to put the value of n here and calculate on satisfy this equation. For example, if I put n is equal to 4, what is the value we will get? 2 the power 4 minus 2. 2 into 2 into 2 into 2 minus 2. 2 to the 4, 4 to the 8, 8 to the 16 minus 2. That is 14. And this one is satisfied. Fine. So what we get? We get n is equal to 4. What we get? N is equal to 4. Fine. I hope everyone understand n is equal to 4. Now, when we get n is equal to 4, now the thing is, what is the meaning of n is equal to 4 here? Fine. So try to understand. Here n is telling, n means number of zeros in CIDR. It means now you have to choose or you have to find out the CIDR in which number of zeros should be 4. Fine. You know, when we convert the CIDR in the binary, we are getting two values, 1 or 0, right? 1 means that is the on bit, 0 means that is the off bit. Fine. So now you have to calculate the CIDR and now you have to find out the CIDR in which the number of zeros should be 4. Fine. So just tell me, total bit in an IP address is total how much? 32 bit. In 32 bit, I need 4 bits should be off. Fine. And on bit will be, how can you find 32 minus 4? How much value you will get? 32 minus 4. 32 minus 4. What we will get? That is 28. That is 28. It means for Zoom network, we are going to assign the CIDR that is /28. Fine. So Zoom, which network we are going to assign? This is the primary network, right? And Zoom is the first client to whom I am going to assign the sub network. Fine. So what I will use? I will use the primary one. So network will be, guys, 192. CR will be 28. Fine. That is the requirement of Zoom. Fine. Now we have a different client, that is WebEx. Fine. So WebEx, we need to assign the network. But the thing is how? Now try to understand. First of all, before assign the next sub network to WebEx, you need to calculate the endpoint of this network which you assign to the Zoom. If you do not calculate the endpoint, how you calculate or how you find the next network? That is not possible. Fine. You need to calculate the endpoint. Fine. Now, how you calculate the endpoint? Fine. So see, we already assign 192.168.10.0/28. That is for, आगे कैमरा में तुम फिर से रिकॉर्ड करो. So finally, we assign this network 192.168.10.0/28 to Zoom. Fine. Now the next client is WebEx. Fine. Now we need to assign the next network to the WebEx. Fine. Now the thing is how we find the next network which I am going to assign to the WebEx. Fine. That is the main thing. Fine. So for this, what we need to do? We need to calculate the endpoint of this network. Endpoint means broadcast ID. Fine. Now, how we calculate the broadcast ID? 192.168.10.0/28. How we calculate the broadcast ID? Fine. Now, /28. First of all, what is the subnet mask for /28? What is the subnet mask for /28? 255.255.255. Fine. 255.255.255. Fine. Then next one will be, guys, 240. Next will be 240. Fine. Now that is the subnet mask. Now you need to calculate the block size. How you calculate the block size? 256 minus subtract the last one, that is 240. Value will be 24. Value will be, yes, 16. 256 minus 240, value will be 16. Fine. So WebEx, we will assign the next network ID, that is 192.168.10 dot, then how much? 16. This network I am going to assign to WebEx. Fine. Now, again, what will be the broadcast address for the Zoom? Just subtract 1 here. What will be the value? 192.168.10.15. That will be the broadcast ID for WebEx. Okay. It means when we calculate the broadcast ID, what we will do? We will just assign the next IP to the next client, that is Zoom. Fine. So to WebEx, we are going to assign 192.168.10.16. Fine. Now, we assign this network, but still we do not calculate the CIDR. Still we do not calculate the CIDR. Now we need to calculate the CIDR. Again, we have to follow the same formula. To the power n minus 2 less than is equal to, then number of requirement is 2. If I put n is equal to 2, if I put n is equal to 2, so to the power 2 minus 2, see, 2 to the 4 minus 2, value will be 2, and this is satisfied. It means what the value I get? N is equal to 2. We get n is equal to 2, and n is telling here number of zeros in the CIDR. Fine. So what will be the exact CIDR? 32 minus 2, that is 30. It means to WebEx, I will assign 192.168.10.16. That network, and CIDR will be 30. So this network I am going to assign to WebEx. Fine. So this way we assign WebEx. Fine. Now come to the next, that is Google. Fine. To Google, the requirement is how much? 50. Fine. So before going to the Google, again, we have to calculate the same thing. First of all, we need to calculate the endpoint of this network. Fine. So endpoint means broadcast IP address. Fine. So 192.168.10.16/30. It means for /30, you need to calculate the subnet mask. What will be the subnet mask? 255, 255, 255, then 252. That will be the subnet mask. How you calculate the block size? 256 minus 252. What will be the value? 4. Value will be 4. It means next network will be 192.168.10 dot. Next one. What the block size you get? 4. You need to add here 4. What I will get? 16 plus 4. That is 20. So this network I am going to assign to whom? Google. Fine. Now again, still we need to calculate what? Still we need to calculate the CIDR. Still we need to calculate the CIDR. The same thing, to the power n minus 2 less than is equal to number of requirement is 50. Number of requirement is 50. If I put n is equal to 6, to the power 6 minus 2 less than is equal to 50. So see now what is the value of to the power 6? 1, 2, 3, 4, 5, 6. 2 to the 4, 4 to the 8, 8 to the 16, 32 and 64. 64 minus 2, that is 62, and that is satisfied. Fine. So n is equal to 6. So n is equal to 6 means that is number of 0. That is number of 0 is equal to 6. So what will be the CIDR? CIDR means 32 minus 6. What will be the value? 32 minus 6. Value will be 26. Fine. So we are going to assign 192.168.10.20 and CIDR value will be 26. Fine. So to Google, I am going to assign 192.168.10.16 and CIDR value will be /26. This I will assign to Google. Fine. Clear? Now, we have a last client, that is Cisco. We have a last client, that is Cisco. Fine. When we assign the Cisco, first of all, again, we have to calculate the broadcast IP address. 192.168.10.10. What? 10.20. Yes, /26, right? Sorry, there is one mistake. You have to just, this one is not 16, that is 20. That is 20, right? Now come here on Cisco. So that is the network ID. For that network ID I assign to Google. Fine. Again, we have to calculate the same way. First, you need to calculate what? You need to calculate the broadcast ID here. How you calculate? /26. For /26, what will be the value? /26. So what is the subnet mask? 255, 255, 255, and then 192. What will be the block size? 256 minus 192. Value will be 64. Fine. So the next network will be 192, 168, 10 plus 20 plus 64. That is 84. This network I am going to assign to Cisco, but still we don't know the CIDR. We need to calculate the CIDR. 2 the power n minus 2 less than is equal to 100. N is equal to what? 7. Fine. So 7 is what? 0. So CIDR will be 32 minus 7. How much? 32 minus 7. That is 25. Yes. So we will assign this one. That is 192, 168, 10.84, and that is /25. So this network I am going to assign Cisco. Fine. So finally, I hope you enjoy or you understand. So this network to Zoom, we are going to assign which network, guys? 192, 168, 10.0, but CIDR will be, guys, CIDR will be /28. This network I will assign to Zoom. Fine. The next one is WebEx. To WebEx, which network we will assign? That is 192, 168, 10. After 10, which network? Yes, 16. Which one? 16. But what will be the CIDR? 30. That will be the CIDR. Fine. Now the next one is Google. To Google, which network we are going to assign? That is 192, 168, 10.20. 10.20, and CIDR value will be 26. CIDR value will be 26. Now come to the Cisco. Cisco 192, 168, 10 dot. How much? 84. Yes. And what will be the CIDR? That is 25. Fine. So this network I will assign to Cisco. Fine. Now in Zoom, the requirement is 10. The Zoom, the requirement is 10. Fine. This is the network ID, right? This is the network ID which I write here. This is the network ID. Fine. This is the network ID. Fine. Now you have to calculate the broadcast. What is the broadcast? Just subtract 1 here. So value will be 192, 168, 10.15. That will be the broadcast for Zoom. What will be the broadcast for this one? Just subtract -1 from the next network. That is 192, 168, 10.19. 10.19. Fine. That will be the broadcast. Yes or no? Yes. Now, here what will be the broadcast? 192, 168, 10 dot. How much? 83. And here 192, 168, 10 dot. How much? How much? Yes, 211. 211. That will be the broadcast. Fine. So basically, what I'm trying to say, this is the range. This is the range for every network. This is the range. Fine. And when you see each and every range, you will understand the requirement is 10 and we are assigning from, for example, 10 to 15. This is the network ID and this is the broadcast ID. These two IP address we are not going to use. So we are going to use from 192, 168, 10.1 to 192, 168, 10.11. Fine. The requirement is 10. So it means our requirement will be fulfilled. There will be a no problem. There will be a no problem. Sorry, not 11. There will be 14. There will be 14 because broadcast ID is 15. So just subtract 1. That is 14. Fine. For second network, what is the range? 192, 168, 10.16 we are not going to use. It means we are going to use from 17. 17 to how much? Yes, 19 we can't use. That is the broadcast. So it means still 18. Fine. For this network, what is? 20 we are not going to use. It means from 21 to how much? 21 to, yes, 83 we are not going to use. It means 82. Here 84 we are not going to use. It means from 85 to how much? 210. This one. So basically this is the way how we can perform the VLSM. Understand, everyone? I hope you understand. Fine. Okay, so this is all about the VLSM. Fine. Thank you very much.